Imagine a city bustling with skyscrapers, only these skyscrapers are galaxies, and the city is a galaxy cluster. Welcome to a world where cosmic neighborhoods teem with activity and life, galaxy clusters within the cosmic web. These clusters are like metropolitan areas of the universe, vibrant with celestial phenomena. A team at the University of Kansas is diving into these cosmic conurbations, striving to uncover the secrets they hold. So what makes these galaxy clusters so fascinating? Let's dive in to find out. Galaxy clusters aren't just random groupings of galaxies. These colossal cosmic entities are intricate tapestries woven with galaxies, hot gas, and dark matter, each playing a crucial role in the formation, structure, and behavior of the cluster. Let's start with the most visible component, the galaxies. A single galaxy cluster can house hundreds to thousands of galaxies, each a whirlpool of billions of stars, interstellar gas, and cosmic dust. These galaxies, however, constitute only about 5% of a cluster's total mass. They're like the glittering skyscrapers in the vast cosmic city that is the galaxy cluster. The hot gas, invisible to our naked eye but detectable through X-ray telescopes, forms the bulk of the observable matter in a cluster. This intra-cluster medium, heated to temperatures of millions of degrees, contributes around 10 to 20% of the total mass. Think of it as the air that fills the spaces between the skyscrapers, only much, much hotter. Now let's delve into the mysterious and elusive dark matter. Although we can't see it or detect it directly, we know it's there because of its gravitational effects on visible matter. Dark matter makes up a staggering 70 to 85% of a galaxy cluster's total mass. It's like the hidden foundation, the invisible bedrock upon which the cosmic city rests. These three elements, galaxies, hot gas, and dark matter, interact within the cluster through the force of gravity. This interaction shapes the cluster's overall structure and behavior, influencing everything from the movement of galaxies to the formation of cosmic structures. But how do these clusters influence the galaxies within them? Time to explore. Galaxies within clusters are not solitary entities. They interact with their surroundings. This is a fundamental concept when we delve into the influence of galaxy clusters. Galaxy clusters are like bustling cities in the cosmic web. And just as cities shape their inhabitants, clusters mold the galaxies within them. They do so by impacting key processes like the baryon cycle and star formation, both of which are pivotal to a galaxy's evolution. But what are these processes? Well, the baryon cycle refers to the flow of baryonic matter, protons, neutrons, and electrons, between galaxies and the intergalactic medium. It's a cosmic exchange program, if you will. Galaxies take in gas from the surrounding space, use it to form stars, and then expel some of it back into the intergalactic medium. This cycle is a galaxy's lifeline. It's what allows galaxies to grow and evolve. Now let's talk about star formation. Stars are born when dense regions of gas in galaxies collapse under their own gravity. This process is influenced by various factors, including the gas density and temperature, and the galaxy's interaction with its environment. Within a galaxy cluster, these processes don't occur in isolation. The cluster environment plays a crucial role. For instance, the hot, dense gas between galaxies in a cluster can prevent cooler gas from falling into a galaxy, thereby affecting its star formation. The gravitational tug-of-war within the cluster can also trigger star formation by compressing the gas within galaxies. It's a cosmic dance, with each galaxy responding to the rhythm set by its cluster. The environment within these clusters is dynamic, ever-changing, and it influences every aspect of a galaxy's life, from its birth to its evolution. So we see that galaxy clusters are not just collections of galaxies, but dynamic environments shaping the galaxies within them. Galaxy clusters are more than just cosmic cities. They're the architects of the universe, shaping and molding galaxies in their cosmic crucible. While galaxy clusters are billions of light years away, astronomers have ways to study them. Yes, these cosmic metropolises, though seemingly out of reach, are the subjects of rigorous study by curious minds seeking to uncover the mysteries of our universe. Astronomers employ a range of methods to investigate these vast clusters. One of the most common ways is by analyzing data from astronomical surveys. These surveys are like cosmic census takers, documenting the various galaxies, their locations, and characteristics. They provide a wealth of information, allowing astronomers to map out galaxy clusters and understand their structure. We can also think of telescopes as our eyes to the cosmos. Modern telescopes are capable of observing light across the entire electromagnetic spectrum. They can detect not just visible light, but also radio waves, infrared, ultraviolet, X-rays, and gamma rays. This allows astronomers to observe galaxy clusters in multiple ways, each providing a unique piece to the cosmic puzzle. In addition to observing light, astronomers also study the way it behaves. As light from distant galaxies passes through galaxy clusters, it can be bent and distorted by gravity in a process known as gravitational lensing. This bending can act like a magnifying glass, revealing galaxies that are even further away and would otherwise be too faint to detect. These observations are not just about understanding galaxy clusters in isolation, but rather how they fit into the larger cosmic web. They allow astronomers to explore how galaxies evolve and interact with their environments, and how these processes affect the cycle of matter and star formation. In essence, studying galaxy clusters is like conducting a grand investigation into the history and future of our universe. And every new piece of data, every observation, is a clue. It's like piecing together a cosmic jigsaw puzzle, each discovery providing a bit more of the picture. Every new observation brings us one step closer to understanding the mysteries of our universe. This understanding helps us to better comprehend our place in the cosmos and perhaps one day might even guide our journey among the stars. Why should we care about these far-off galaxy clusters, you might ask? Well, the importance of studying these astronomical phenomena goes beyond mere curiosity. Galaxy clusters, as the largest structures in the universe held together by gravity, serve as cosmic laboratories for scientists. They provide a unique platform to test theories of cosmology, the scientific study of the universe's origin, evolution, and eventual fate. By studying these cosmic cities, we are able to gain insights into the universe's formation and evolution. We can observe galaxies in different stages of development, from infant galaxies still forming their first stars to elder galaxies that have long ceased star production. This allows us to construct a chronological narrative of galaxy evolution, much like piecing together a cosmic jigsaw puzzle. Moreover, these clusters are rich in dark matter, an elusive substance that makes up about 85% of the universe's matter, but remains largely undetected. By analyzing the gravitational effects within these clusters, we can indirectly study the properties of dark matter. This could potentially answer one of the biggest questions in cosmology: what is the universe truly made of? But it doesn't end there. Galaxy clusters also act as cosmic lenses, bending and magnifying the light of objects behind them due to their immense gravity. This gravitational lensing effect allows us to observe objects that would otherwise be too distant or faint, further broadening our cosmic horizon. In studying galaxy clusters, we are not just looking at distant galaxies, but probing the very fabric of the universe itself. Galaxy clusters, the cities of the cosmos, are more than just fascinating spectacles. They are celestial hubs, brimming with billions of stars, planets, and the mysteries of the universe. Throughout our cosmic journey today, we've ventured into the heart of these galactic metropolises, unveiling their structure, their influence, and the incredible methods we use to observe them. We've seen how these clusters, interwoven in the cosmic web, are not just passive bystanders in the universe. Instead, they actively shape the evolution of galaxies, impacting star formation and the baryon cycle. Moreover, they offer us a unique lens to peer back into the universe's history, aiding us in our quest to decipher the cosmos. But remember, our exploration of these cosmic cities has just begun. There's a universe of wonder out there, waiting to be discovered. And we invite you to continue this journey with us. Remember, every star in the night sky is a call to explore. So don't forget to like, subscribe, and share your thoughts about these cosmic cities in the comments below. Let's journey together through this universe of wonder.